Okay. So here on this one, they're giving us a result, and they want us to come up with the formula. They're saying write an explicit formula for this sequence, and then they give us the sequence. So so what I'm saying is this is that we got to have some kind of formula where you plug in n equals 1 and you get minus 1/6. And then that same formula, if you plug in n equals 2, you get positive 1/7. And then that same formula, you plug in n equals 3 and you get negative 1/8. And that same formula, you plug in n equals 4 and you get 1/9. That same formula, you plug in n equals 5, you get negative 1/10. And that same formula, you plug in n equals 6 and you get positive 1/11. How could that be? Does such a formula exist? Is there some kind of formula that's going to make those numbers happen when you plug in 1, 2, 3, 4, 5, and 6? Well, let's do this. In order to help, let's forget about the negative signs first off. Just pretend they're all positive. We'll deal with the negative thing. I've got a trick I'll show you. It's actually really easy. But let's set that aside for a minute. Let's just pretend they're all positive. Can you think of a formula? Some kind of, like 3n plus 7, or, some kind of n formula that we could plug in, n equals 1, 2, 3, 4, 5, and 6, and get these numbers just all positive. Forget about the negative. We'll do that in a minute. How's that going to work? What could that formula be? Do you see the connection between, so this right now what we're doing is mathematical scientific thinking at its heart. This is good. This is really good. Is the ability to look at a pattern and figure it out. So think about, how does 1 connect to 6? How does 2 connect to 7? How does 3 connect to 8? How does 4 connect to 9? Do you see the relationship, etc.? What's the relationship there? What's the connection? Do you see it? Do you see how it's always 5 higher? Add 5. 1, add 5. That's 6. 2, add 5. That's 7. 3, add 5. That's 8. 4, add 5. That's 9, etc. Add 5. That's 10. 6, add 5. That's 11. Right? It's just adding 5 every time. Do you see that? You just take the n number and you add 5, and that gets you the denominator, doesn't it? You see that connection? So then we go, oh, okay. So our formula is going to be n plus 5, 1 over n plus 5, other than the negative stuff, which we're going to handle in just a minute. Right? You agree so far? If you take that formula and you plug in a 1, you're going to get 1 over 6. Yeah, other than the negative. Plug in a 2, 1 over 7. Yeah. Plug in a 3, 1 over 8, other than the negative. We'll fix that in a minute. Yeah, it's working, isn't it? You see how that formula works? Now, what about the negative? Well, here's the trick. See how the negative switches? See how it's negative, positive, negative, positive, negative, positive? It's switching. They do that all the time. When you have a sign switching, negative, positive, negative, back and forth like that, there's 2 things that'll do that. It's negative 1 to the n if it starts negative, and there's negative 1 to the n plus 1 if it starts positive. Why? Well, you can tell how that works, right? If you put a 1 here, start means n equals 1. Negative 1 to the 1 is just negative 1, but if you put in a 2, see how it'll, negative 1 squared is back to positive, and then 3, it's back to negative again. 3 negatives is negative. And then 4 negatives is back to positive. See the trick? And if you just do n, when you put in 1, you start at 1, right? N equals 1 is the first term always. You put in a 1, that'll start out negative. Whereas here, if you put in a 1, 1 plus 1 is 2. Negative 1 squared is positive. It'll start out positive. So that's the trick. What does ours do? Ours starts out negative. So then I just grab this and I go, okay, just make it -1 to the end. And there it is. There's the formula. That'll work. Let's test it. Let's see if it's right. If I take n equals 1 and I put in a 1 here, that's going to be -1 on the top and 1 here. It's going to be -1/6. Yeah, beautiful. See? -1/6. Put in a 2. Put a 2 here for n everywhere. -1 squared, that's +1 over 5 + 2, 7. Yeah, see how it's working perfectly? That's the formula that's producing all these terms. So there we go. What we just did is called, what's it called? Inductive logic. This is inductive logic. And it's at the heartbeat of science. Because if you think about it, what do scientists do? They look at the human body, for example, or outer space, or microscopic things, or magnetic forces, and things in nature in our body, nature in the sky, nature wherever, things in the created universe, and they say, hey, what's the pattern? They look and they go, look at how things fly through the air, look at how things move in the human body, look at how, whatever, and they go, what's the pattern there? What's the rule? What's the formula making that happen? So when you go from something you observe, back to the rule making that happen, that's called inductive logic. That's the heartbeat of science. And that's what we just did. There we go.